Hello everyone, in this video I'm going to talk about network concepts and basically focusing only on the definitions, the terminology that is needed to understand this particular topic. If you are in standard maths in year 12 for HSC preparation, or if you are with the new NSW syllabus in year 10, you would still be required to understand this basic terminology. Now, before you even begin what the terminology of network concepts is, network is simply connecting different, think like you can connecting different computers with cables, or connecting different cities with roads. So they all consist of a path and a way to connect from one city to the other city. Now, Facebook network is a more complex network that they have used and applied the algorithms of the computer, where one person has different friends and in turn they're all connected, and the way a friend of a friend is my friend, that's a saying. So that's what it is. So we will see how you can achieve different paths or different ways to connect from one node or one vertex to another vertex, and what are the different ways that a person could take. And these can be understood with some examples later on, but I would like to start introducing this terminology right here. So, what is a network? A network is a group of objects that have some sort of connection. So, that's what I'm trying to say. So, if you look at the cities that are connected with the roadways, that whole entire network of road systems, highways, that's our network. So we have some cities and they're all connected through roads. So here a network is made up of vertices. So these little black dots, they are called vertices or nodes. Vertex is a singular form of vertices. Now edges are these green lines. Now, most of the time, when I draw my network, I try to think that they have to be straight, but not necessarily. The edges can be curved. Basically, they don't actually have to be straight. Okay. Now, even in the circuit electronic world, how you connect your resistors, capacitors, induct, your voltage, all that is an electric network. So basically, a network is how you connect objects that are involved in it. Now, in this picture, you can see that 1, 2, 3, 4, 5. There are 5 vertices, and 1, 2, 3, 4, 5, 6, and 7. There are 7 edges. Now, a network diagram is a representation of a network. Diagrams drawn for the same network might differ in appearance but still represent the same connection. Now, furthermore, now this is where more complex um, definitions will come into picture. But before even we do that, I want you to understand what a path is. A path is a way through a network or a part of a network, not necessarily that you're covering everything, passing through vertices and traveling along the edges at most once. What is a connected network? Is one way the path between there's a connection or a connectivity between any two vertices. So that becomes a connected network. A walk is a set of edges in succession, meaning the end of one vertex should be the beginning or the start of the other edge. So we'll be using walks, and then what is a cycle? A cycle have to be a closed walk. So it is not also nothing but a walk, but you start and end at the same vertex. The first and the last vertices must be the same, and no other vertices are repeated. Now that's very, very important to understand, because there are situations and examples where we will come across where we don't want to repeat a vertex. Like, for example, if you're already placing a gas connection or something like that, a utility, you don't want to keep repeating the same um, vertex. Like you just can move on and try to figure out how can we create a connection and get the work done instead of like coming back to the same houses and then go again. Anyway, so the degree of a vertex is the number of edges that connect to that vertex. So for example, if you look at this one right here, where my cursor is pointing, it's one, two, three. So these three are connected to this vertex. So this is called the vertex degree is 3. Whereas for this one, it's 1, 2, 3, 4. The degree is 4. So if it's an odd number, you call an odd degree vertex, even degree vertex. So simple. But identifying the degree of a vertex is important as we move into complex algorithms in the network concept. So these are some basic definitions. Think like these are your ABCs of the understanding of network, and we'll be using a lot of the same terminology. So please get used to that. A walk, again, I'll repeat. The end vertex of one edge must be the start vertex of the following edge. We talked about the cycles and we talked about the degree. So, yep. Thanks, guys. Thanks for watching. And I hope you continue to watch the next video. So, as we proceed, I'll be going through directed networks and how do you identify the weights of the edges. All right. Thanks for watching.